Good morning, and thank you all for joining us for our webinar today as we introduce you to the powerful capabilities of 3D Experience Delmia NC Shop Floor Programmer, a comprehensive solution for CNC programming and shop floor management. Today, we are joined by Lindsay Morrison, the Director of Digital Manufacturing at CAD Micro. Before I hand things over to Lindsay to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the Q&A pop-up as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded, and we'll be sending you the recording via email tomorrow. If any questions do arise afterwards, you can feel free to reach out to us and we'll be in touch shortly. A little bit about CAD Micro. We were founded in 1984 and are a 100% Canadian owned and operated company. We are present coast to coast across Canada with 6 offices. Our mission is to empower clients with advanced technologies to innovate and succeed. We offer solutions across 5 oceans: design automation software, advanced manufacturing solutions, advanced simulation software, 3D metrology and scanning technology, and professional services in AR, VR, and XR. All right, without further ado, I will pass things over to Lindsay to get us started.
Okay, thanks, Shreya. My name is Lindsay Morrison, and I am the Director of Digital Manufacturing here at CAD Micro. So I'll be covering the webinar today on Delmia NC Shop Floor Programmer. So just a quick overview of what we'll be talking about today. So why use CAM software on the platform? Some collaboration tools that I really find helpful with the platform. What is the actual role of Delmia Shop Floor Programmer? Some more 3D Experience CAM roles, what the 3D Experience has to offer for CAM. We'll go over a quick demonstration of the actual role and how that works, and then we'll finish with some questions. So CAM software on the platform, what is it? Why do we want to use it? That kind of thing. So basically, we have improved collaboration and data management. So the 3D Experience platform provides cloud-based file management. So it allows a lot more collaboration and easier to use collaboration between team members and people in your company. So this is probably the number one reason why you would want to use the platform in general, let alone just the CAM software. So it offers full access to a design's entire history, making it simple to track changes and revisions. Faster performance is also a big factor. So large assemblies load much quicker on the cloud-based platform compared to local machines. And then running simulations on the cloud is significantly faster than on your local computers. Enhanced accessibility. The platform's compatible with all devices, so that's phones, tablets. You can kind of see in the image here. We can have meetings anywhere. We can view simulations, that kind of thing, on any kind of device. So that's extremely helpful. Machinists and programmers can easily share designs with external consultants or manufacturers. So again, in manufacturing, this is useful because we are sharing data and files all the time, not only just inside our company, but again, outside the company if you are outsourcing anything. Real-time updates. So the platform pushes updates live as they become available. So again, similar to smartphone updates and any kind of platform that you're using outside of work. Integrated workflow, the 3D Experience platform encourages programming inside a full machine environment. So again, bring in that whole machine, that whole CNC machine, and we can simulate right inside that machine, and we can show that whole assembly in, and we're not going to lose any performance. It offers improved associativity between objects like cutting tools to inventory and features to engineering manufacturing data. And number 6 being enhanced tool path control and validation. So the NC Shop Floor Programmer apps on the platform provide more tool path level control and better tool path validation compared to traditional CAM solutions. So again, we can bring that whole machine in, we can validate right in the machine, we're programming right in the machine. and you can see and preview while you're programming. You don't need to wait till the end. You don't need to finish the program in order to preview that in the machine. So I've got a really quick video here talking about 3D Lean, which is one of my favorite collaboration tools on the platform. This is extremely helpful for any company out there that is doing any kind of manufacturing, engineering, design. This tool is super helpful, and I think that all companies can benefit from it. So take a look at this video. So I really think that 3D Lean can enhance meetings, it can enhance collaboration between all departments in any company. So I really think that that's a big benefit for the 3D Experience platform in general, but also obviously for the CAM and manufacturing side of things. So what is the Delmia NC shop floor programmer role? It's a CAM software within the 3D Experience platform. It outputs readable code for your CNC machine. So directly in that software, we can create CNC code. It includes 3-axis milling. So that's 3 plus 2-axis pre-positioning as well. Intelligent data management, full CAD associativity, and then again, like collaboration tools like 3D Lean. So there are other CNC roles that come on the platform. So you can kind of see a preview of a bunch of different roles here. Again, shop floor programmer is one of kind of our intro roles to CAM programming, but you can have more functionality and go up from there or add turning in, that kind of thing with other roles. They've also created some kind of packages they call offers. And these are more affordable, but combine multiple different roles. So Delmia Shop Floor Programmer is, again, that first package. Then we can go up to, say, for example, Turning Professional if you're doing more turning. A Milling Professional package, 3 plus 2-axis, specific automation for mold and die processes. And then there's also the milling and turning premium. So that's the full kind of 5-axis, the full package. It includes basically everything. So multiple different offers or packages for the 3D Experience platform. And now we'll hop into the demonstration. We'll show the import from a SolidWorks design CAD file to the platform. Then we'll program the part using NC Shop Floor Programmer role, and then we'll post-process to the CNC machine. So I've gone ahead and opened the part that we're going to program inside of SolidWorks. And this is going to be saved onto the platform, and then we'll use Shop Floor Programmer to program the part. So the first thing that I want to do is I want to save this. You'll notice that I have the Lifecycle and Collaboration tab open inside my Command Manager. And I've also got the 3D Experience tab open on the right here. So when I choose my add-ins and choose 3D Experience, this is where I'm going to see that. So when I want to save this, I'm going to choose Save with Options here on the top. And again, there's the same buttons down here in the bottom of this tab here. So it's going to go ahead and extract the file information. It's going to bring up my options page. And I'm actually going to save this to a bookmark so that it's a little bit easier to find once I get onto the platform. So we've got my file added in. This is actually where I could create a new revision. This hasn't been saved to the platform yet, so I'm not able to create a new revision. But if I was to come back, make some changes to the part, I would just check this off and it would create the revision for me. So I'll save that to the platform. You'll also notice that I've added a coordinate system onto the part. So if you know where your work offset is going to be or any coordinates to locate the part, I highly recommend adding those in the design first, and then we don't have to add it in later. So let's switch over onto the platform. So I'm just bringing up my browser and I've opened up 3D Experience in here. So I've got my bookmark editor open here. If I scroll down here and go to my bookmark, we should be able to see our part located inside the bookmark. I didn't lock my part from SolidWorks, so you can see that it's not locked. I have the lock key here. I can also lock from above. I'm going to go ahead and lock that. You can see there's the key there. And if we scroll over here too, you can also see the little check mark showing that it's been updated. If I come back into the platform, I'm going to refresh. And we should now see that this part is locked. So again, any changes that are made inside of SolidWorks will also reflect onto that part. And then it also shows the revision inside this window as well. I've also got my tasks open on the right-hand side here. So you can see I'm currently working on last week's project. That's now completed, so I can just drag that over into the completed area. I could also open that up and maybe move it to approval. There's a whole bunch of different options within inside the tasks as well. I'm now going to create my CNC program. So if I go into information, we can scroll down. So this is the task that's been created. It's currently under to do. And I'm going to attach that file here. So I'm just basically going to drag my base file into the attachment. And now I've got the actual part file in here. So this is where I can take a look at what part needs to be programmed, and I can actually open that directly into my app. So I'm going to go ahead and save that. And you can see under members that it has been assigned to myself. So I need to program that. Okay, so now I'm going to move that over into in work, and now I'm going to work on that project. So the next thing I'm going to do is I'm going to open my shop floor machining app. So I'm just going to click on shop floor machining. That's going to launch shop floor machining app. And the app is now open. So I've just moved it onto the side of the screen because I'm going to add in my machine that I'm going to work with. So I'm going to locate the NSR folder that I've got created here, and I've got some machine templates available. So we can open this up a little bit larger so that we can see what we're doing here. So then I'm going to go ahead and use my 3-axis imperial machine. I'll go ahead and drag that into my manufacturing cell inside of shop floor machining. And that's going to hold my machine and my tools. So this is a template we've created to hold all of the necessary objects that we need to program this part. This machine is not going to be visible. It is just a generic machine that we've created. However, you can create the actual machine. You can have all of the CAD files in there so that you can view the machine and everything that is included with it. We can also add in fixtures, so your vise, the table, all of the components that you would need on that machine to be able to simulate and view the actual program running inside the machine. So the next thing that I'm going to do is I'm going to open up the actual app. So here's my app in full screen. You can see in here we've got the machine, we've got the tool crib. I can open this up and see all of the different tools inside here. And then what we're going to do is we're going to import our part file. So I can use the shop floor machining wizard on the right hand side of the screen here. This is a really helpful tool for new users. It will go ahead and list all of the different processes that need to be done in order to complete the program. So the first thing would be to obviously import the product, which is the actual part file that we're going to be importing. So we can click on that button. It's looking for a product, so I can either search in the top search bar here, or I can find it from my bookmarks. So what I'm going to do is I'm going to use the search bar, and this was called base CMS. So there's my part, and I'll go ahead and open that. So now that I've added my part into my program, I'm going to go ahead and set up my stock as the first step. So you can see that there's a rough stock button at the bottom here. You'll also see that that's the next operation that I need to make. So I can choose rough stock. And this is basically going to either take a look at my part and put a bounding box around it, or we can bring in another body, whatever we need to use to create the stock. I'm just going to use the bounding box. So I'm going to go ahead and choose select part body. I click on the part body and then I can adjust the parameters to the size of the stock. So I'm going to leave that as is and we'll go ahead and choose OK. Once I've done that, you can see that I've created the stock inside my assembly manufacturing product, which is the part. So those are associated together now. And then the next thing I want to do is I'm going to come into my part operation here, and I'm going to set the stock and the part itself up inside the part operation, as well as the work offset. We can double click on part operation 1. I'm going to choose my assembly manufacturing product. And everything that has a check mark has already been selected. So we can either change those options or we can just fill out the rest of the things that need to be done. So you can see the design part and the stock have not been selected. There's no check mark beside them. So I'm going to start with the stock. I'm going to click on the stock on the screen. And now you can see there's a check mark beside my rough stock. In order to select the actual part file, I like to hide the stock. So I'm just going to choose my hide show option here, and we'll go ahead and hide and show the stock. So we've hidden the stock, and now we can click on design part and choose that as our design part. If we had any fixtures, we can add those in as fixtures here. We can add a safety plane, so I can choose that top face and say maybe 5 inches above that face would be my safety plane. Okay, and the next thing that I want to do is I actually want to set up my machining axis. So I'm going to go ahead and choose that. We'll choose origin, and I'm going to choose the axes that I had created inside of SolidWorks. So I just want to zoom in here and click on the axes. So once I've got that set up, I'm going to go ahead and press OK. And we've set that as our machining axis for our first setup. We needed more setups. You can see that there's a little setup drop down, and we can actually add in more setups here. So I'm going to go ahead and call this my G54, and I'm going to choose OK. So now that I have my coordinate system set, I'm ready to add in my toolpath. So the first thing that I'm going to add in is going to be a pocket. So I'll go ahead and create a prismatic machining toolpath. So you can see we've got prismatic, we've got surface machining, so a whole bunch of different toolpaths in here, and axial, which would be more of the drilling. So inside prismatic machining, I'm going to go ahead and I'm going to add in a pocket. It's going to ask me which tool that I want to use. So automatically it will bring up my tooling list and allow me to choose a tool. So this is end mills. I'm going to go ahead and choose my 3/8 end mill. And then it wants me to select a contour. So I'm going to go ahead and select the bottom contour here. And then I want it to wrap around. So I'm going to click on and navigate on belt of edges, and that will close the contour. And then we can go ahead and choose the green check mark. And now I've got my toolpath window that's going to open up. So the first one here is the actual tool. So this is the resource that I've selected. You can see the tool preview in here. We'll go ahead into the geometry tab. And this is where my bottom plane would be selected. So I can click on that. I'm at the bottom face of the part. You can see I've chosen my contour. We've got the tool axis and which direction it is. We've got start point, end point of the tool path. We also want to set the top plane, so where the tool path will start cutting. There are a whole bunch of different settings within this window and lots of different options that we can choose from. So this is a closed pocket. The bottom is either hard or soft. We can come into our strategy tab as well. You can see inside the strategy tab is how we actually want to program this tool path. So is this going to be in a helical motion? Is it a kind of zigzag back and forth motion? How do we want to cut this? And as you can see, there's also tabs on the left-hand side that we can click through and adjust different settings in here as well. So if I want multiple depth cuts, I can say number of levels and maybe set this to 3. Once I've got the settings that I want to start seeing, I can press display and you can actually get a nice little preview of what the toolpath looks like so far. That's the levels, and then the next one would be if I wanted to add in a finishing pass. We've also got high-speed machining toolpath settings. If we go into the next tab, we've got tool axis settings, collisions, the kinematics. Inside macros, this is where we can actually adjust how we want to approach and retract from the part. So this one's currently set as build by user. If I go to edit here, I can actually build an approach strategy and how I want to approach the actual pocket. So this is currently just doing a plunge in. So I can go ahead and manipulate how I want to actually set this up. So you can see I can add in, if we hover over it, it says add motion to align, add distance, axial motion. So again, we can add just by clicking on it, and you can add distances in here. You can add helix. There's a whole bunch of different options in here. Another option would be to drop this down and use different parameters. So in this case, I could press OK, and now I'm using a ramping approach, and then I've got a retract in here as well. So we can press display, and we can see the ramp motion on the entry. The next tab in here is the feeds and speeds tab. So this would be obviously where you enter all of the feeds and speeds for this toolpath. Once we've got the toolpath created, we can press OK, or you can simulate directly from in the toolpath. You can also right click on the toolpath here, and you can see there's a whole bunch of different compute options. This will generate the toolpath and it will also simulate. So compute toolpath, compute and check toolpath, and then we can view a quick simulation of the actual toolpath. So I can play through this, and it might go a little bit quick, but I can always slow down the speed. I can also just drag it through, and show the first pass, second pass, and the third pass on that pocket. So if I'm happy with that, I can go ahead and copy that and paste it on the next pocket. So I'm going to highlight it in the list here. And then you can see on every tab, there's a cut copy option. So we can choose copy. And then I'm just going to select it again and choose paste, and it will paste it right underneath. So it's going to use the same tool. I'm going to create the second pocket. All I need to do is I need to move it over to this pocket instead. So I'm going to double click on the pocket. So I'm going to need to change the contour. So I'm going to go ahead and erase this. So remove the contour selection that's currently in there. I'll choose contour again, and now I can select this contour instead. So again, I'm going to navigate on belt of edges to select the whole thing. Okay, so the bottom plane and the top plane will be the same, and I can either display, simulate, or press OK. And then I can go ahead and compute and check toolpath. Okay, so it does its rapid move in, then it does the ramping motion, and it will cut the first one again. So the next thing that I might want to add to this program would be the drilling operations. So we can go into axial machining, and you can see I have drilling here. There's also an option right beside that for automatic hole search. You can also see if I open this up, we also have feature recognition for other machinable features. So in this case, I'm just going to search for the holes, recognize all holes on the part. I'm going to go ahead and search. It's found 16 holes. I'll go ahead and create those features. So 4 simple holes and 12 complex holes. We'll go ahead and choose OK. And then it filters out the actual holes in the window here. So I'm going to select the last toolpath that I have in my tree. I'm going to choose drilling, and then I need to select the holes. So I'll come in here and I'm going to select all 4 of these holes, just the simple holes. Then I'm going to choose which surface is the hole top. So I'll choose this top surface, choose OK, any check fixtures, and then I'm going to choose the hole bottom. And I can choose, again, a whole bunch of different parameters. So this is a through hole, this is the diameter. I'm going to choose a different tool. Okay, and then if I need to make any other changes to the toolpath, I can do so in here. So we'll go ahead and press display, and we should see our 4 drilling toolpaths. Okay, and we can also simulate and view the drill toolpaths. And once we're happy with that, we can choose OK. So now we can see we've got tool change 1 for our 2 pockets, and the second tool change to the drill for our drilling toolpath. So at this point, I might want to post-process my program. I'm going to go into the Analysis and Output tab, and you can see I have the button for Generate NC Code. I'm going to come into my NC Code tab, and I'm going to choose the post that I want to use with this one. Then I'll go ahead and press Execute. And you can see all of the files that it's created. So this will be my NC code. I can open that up and we can see my G code that's been created.
All right. That's about all we have time for today. If any questions do arise after we finish here, please do not hesitate to reach out to us or reply to the webinar email and we'll be in touch. Once again, thank you so much for a great presentation and thank you all for joining. We hope to see you again soon. Thank you.